Welcome back to MathSpark. In this video, we're going to wrap up the 3 active homework problems. So if you recall, we were talking about the paradigm for homework that we're using in college, that it's not just practice, but also how we examine and communicate our thought process, as well as a 4-step problem-solving process developed by George Poya for handling math and science problems. So we've taken a look at 2 examples. Now let's focus on the 3rd and final example that comes from the trigonometry diagnostic test. So we need to grab a piece of scratch paper and get going. Step 1, understand the problem. So let's copy it down. So simplify x plus 9 divided by x plus 4 divided by the quantity x squared plus 18x plus 81 over x squared plus 4x times 4x divided by x squared plus 13x plus 36. So a problem like this, to simplify something, simplify is a pretty nebulous term in mathematics, but generically it means to write it in as simple a form as possible, in a form that involves the least amount of stuff in it. So I'm going to have to use a couple of context clues here. My context clues is that I'm looking at a product and quotient of fractions. And so I might have a basic outline in the following 2 steps. First, I could actually work out the products and quotients of these fractions by using the order of operations, so working my way from the parentheses out. And then I could factor and cancel the terms in the resulting fraction to see if I could clean it up. It's not much of a plan, but it's a start, so let's see if we can carry it out. So let's start by writing this expression down and working our way through it nice and slow. Based on the order of operations, that's what the OO stood for, the first thing I'm going to have to work on is the expression inside the parentheses. To multiply fractions is the same thing as to multiply the numerators and then to multiply the denominators. So if I multiply across the top, we're going to have this quadratic times 4x, so 4x times x squared plus 18x plus 81. And if we multiply the 2 expressions on the bottom, we're going to have x squared plus 4x times x squared plus 13x plus 36. So now we just have a giant division problem. The first fraction divided by the second fraction. To divide by a fraction is to multiply by its reciprocal. So we'll take the reciprocal of the second fraction, which is x squared plus 4x times x squared plus 13x plus 36, all over 4x times the quadratic x squared plus 18x plus 81. And then we have another fraction to multiply through. So if we multiply the factors of the numerator together, we're going to have an x plus 9 times an x squared plus 4x times an x squared plus 13x plus 36, all over, and if we multiply the factors along the bottom, we're going to have an x plus 4 times a 4x, which I'll put up in the front, times an x squared plus 18x plus 81. That takes care of the first step. Now I have a single fraction, and the way to simplify a fraction is to factor the top and bottom and then to find any common terms that we could cancel. So let's work our way through it. The first piece, x plus 9, is already a linear term, so it's factored. The second piece, x squared plus 4x. In the first example, we talked about 2 methods to factoring things, the first of which was to pull out any term who's common to everybody. In this case, there's an x common to both pieces, so I'm going to factor an x out, which will leave an x plus 4. And since both of those are linear, I'm not going to be able to factor those any further. In the numerator, we also have this quadratic, so I can attempt to factor the quadratic by trying to undo the trinomial. So if I keep in mind the process for doing that, we're going to take 2 monomials and multiply them together, and we would like the total to be an x squared plus 13x plus 36. Now if I was going to break this thing up using the rectangular method, it would suggest that the first 2 terms had better be x's to get the x squared. The last 2 terms have to multiply to get me 36. One of the common ways to do that would be 6 times 6. So I could see what would happen if I used 6's here. I'd have x times 6 is 6x, x times 6 is 6x, and that would get me a total of x squared, plus 6x, which is 12x, not 13x. So this is an incorrect factorization. No problem. Let's just go and find another set of factors. 9 and 4 work to get 36. So I could try a 9 and a 4. So we'd see x times x is x squared, 9x, 4x, and 36. That's going to give me a total of x squared plus 9x plus 4x, which is 13x plus 36. And so that's the factoring we want, an x plus 9 and an x plus 4. All right, let's turn our attention now to the denominator. The first couple of terms, the 4x and the x plus 4, have already been factored. We also have a trinomial in the denominator, and with a little trial and error, you'll see that this factors into x plus 9 times x plus 9. So we've got the factorizations. Let me clean this up a little bit. In the numerator, we had an x plus 4 quantity squared, and an x plus 9 quantity squared. In the denominator, we have a 4x times an x plus 4 times an x plus 9 quantity squared. So we've factored the numerator and denominators completely. And now we can look for cancellations. The x in the numerator cancels with the x in the denominator. One of the x plus 4s in the denominator cancels with one of the x plus 4s in the numerator. And then the x plus 9 squared in the numerator and denominators cancel completely. And so that's going to leave me a grand total of an x plus 4 divided by a 4. And so there's our final simplified answer. That brings us to the last step in the POYA process, looking back at what we've done. The first thing we always look back on is there any way to check our answer? Now, there was an awful lot of work that went into this one, factoring and canceling and things like that. So the first thing I'm going to do is just try to do a reasonable check. There isn't any reason at all to believe that these two expressions should match. In other words, can we check whether the initial expression is the same thing as our final simplified expression? One of the ways to check for reasonableness is to simply check whether or not this happens at a specific point, say at x equals 1. If I were to plug 1 in for all the x's, we would have 10 over 5 divided by 1 plus 18 plus 81 over 1 plus 4 times 4 over 1 plus 13 plus 36. And we would have to check whether or not that was equal to 5 over 4. The nice part about that is that that's just an arithmetic problem. So let me add myself a second piece of paper, because I'm clearly running out of room, and continue on with the work. So let's handle the expression on the left-hand side. 10 divided by 5 is 2. On the top, we've got 1 plus 81, which is 82, plus 18 is 100, divided by 5, times 4 over 1 plus 13 is 14, plus 36 is 50. And the question is that the same thing as 5/4? Well, let's see. 50 goes into 100 twice. And so we're going to have 2 divided by 8/5. But to divide by a fraction is to multiply by its reciprocal, so that's 2 times 5/8. 2 goes into 8 4 times, and we're left with 5/4. So the two expressions do match, at least at x equals 1. That's a nice reasonable check. We could even go back and test it at another point if we had the time for it. Are there any other ways to check? Well, one of them might be to go back and re-examine our process in hindsight. In our original plan, we did the multiplication first and then canceled at the very, very end. However, given how complicated some of those expressions were, maybe we could have added a step 0 if you'd like, and factor and cancel where it was possible. To see how this might have worked, let me go back and start with the original expression again, x plus 9 over x plus 4, divided by x squared plus 18x plus 81 over x squared plus 4x, times 4x over x squared plus 13x plus 36. Let's see if we could have factored and canceled where it was possible first. For example, we already saw that in the second expression, we could factor the numerator as x plus 9 times x plus 9 over x times x plus 4. And the last expression was factored as a 4x up top and an x plus 9 times an x plus 4 down below. We factored it first. Unfortunately, there's absolutely no cancellations in either one of these two individual expressions. So let's continue on. We're going to have an x plus 9 divided by an x plus 4 divided by, now to multiply expressions, we multiply across the top. So we're going to have a 4x times an x plus 9 times an x plus 9. Along the bottom, we're going to have an x times an x plus 4 times a 9 times an x plus 4. So it's an x times an x plus 4 squared times an x plus 9. At this point, we can make a cancellation. One of the x plus 9s will cancel. Also, one of the x's will cancel. And so we're going to have the simpler quotient, x plus 9 over x plus 4, divided by 4 times x plus 9 over x plus 4 quantity squared. Now to divide by a fraction is to multiply by its reciprocal, so x plus 9 over x plus 4. We're going to multiply by x plus 4 squared over 4 times x plus 9, which will get us an x plus 4 squared times x plus 9, multiplying across the top. Across the denominator, a 4 times x plus 4 times an x plus 9. And then once again, the x plus 9s are going to cancel. The x plus 4s are going to cancel. And once again, that's going to leave us with an x plus 4 over 4, which is what we got the first time round. In some sense, I like this solution a little bit better because it's constantly keeping us thinking about the simplification process. And so I'm actually going to go and decide, in hindsight, that I'm going to use this as my solution instead of the work I had above. So let me just annotate it a little bit. We did a factor, we did a cancel, we did a simplify, we did the reciprocal, we canceled again, and then we did one last simplify. And so here we have our final work. With that, we've completed all 3 of our active homework examples. So when we come back for the next video, we're going to talk about the next important skill, time management, for when you actually start enrolling in your first college courses.